In some situations, you may be required to convert a solid of one shape to another shape. To illustrate, when we cut a watermelon into slices, we are converting a solid shape into other solid shapes. Regardless of the size and shape of the slices, there is one fact that holds true for the whole process. The volume of all the slices together exactly equals the volume of the original watermelon. So volume is preserved. Let us consider another example, in which we convert a solid of a given shape to a solid of another shape. The surface area usually changes. That is, if we want a candle of any special shape, we will have to heat the wax, or the existing candle, in a metal container, till it becomes completely liquid. Then, you will have to pour it into another container, or mold, which has the special shape that you want. On cooling, we will obtain a candle of the special shape that we want. Here, we should notice that the volume of the new candle will be the same as the volume of the earlier candle, but, whereas, the surface area of the new candle will be different from the surface area of the earlier candle. Let us see few more examples, in which one solid is converted into another solid. Here, a metal in the shape of a cuboid is converted into spherical metal balls of different sizes. Then, we would notice that the volume of first object is equal to the volume of all the second objects. That is, volume of object 1 equals n into volume of object 2, where n is the number of objects that got converted. Whereas, the surface of the first object is not the same as that of the second object. Consider a scenario in which a large metal sphere is converted into smaller metal marbles. We would observe that the volume of the bigger metal sphere equals n into volume of each smaller marbles, where n is the number of smaller marbles that got converted. And we notice that the surface area of the metal sphere is not the same as that of the surface area of each marble. Similarly, when a copper cube is converted into smaller pipes, we would observe that volume of copper cube equals n into volume of the pipe, where n is the number of pipes that got converted. And the surface area of the copper cube is not the same as that of the surface area of each of the pipe. Let us see some examples involving the concepts discussed. Example 1. A cone of height 20 centimeters and radius of base 5 centimeters is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Answer. Given radius of cone, r equals 5 centimeters. Height of cone, h equals 20 centimeters. From the problem statement, we have volume of cone equals volume of sphere formed. Therefore, now we find the volume of cone. We know that volume of the cone equals 1 by 3 into pi r square into h. On substituting the values of r equals 5 centimeters and h equals 20 centimeters, we have. This implies that volume of the cone equals 1 by 3 into pi into 5 into 5 into 20 centimeters cube. This implies that volume of the cone equals 1 by 3 into 500 pi centimeters cube. Since the volume of clay in the form of the cone and the sphere remains the same, volume of the sphere equals volume of the cone. This implies that 4 by 3 into pi into r cube equals 1 by 3 into 1 by 3 into 500 into pi, where 4 by 3 into pi into r cube is the volume of sphere, and 1 by 3 into 500 into pi is the volume of cone. Cancelling pi on both sides and rearranging the terms, we have r cube equals 1 by 3 into 500 into 3 by 4. This implies that r cube equals 125. This implies that r cube equals 5 cube. This implies that r equals 5. Therefore, the radius of the sphere is 5 centimeters. Example 2. Selva's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, an underground tank, which is in the shape of a cubit. The sump has dimensions 1.57 meters into 1.44 meters into 95 centimeters. The overhead tank has its radius 60 centimeters and height 95 centimeters. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump, which had been full. Compare the capacity of the tank with that of the sump. Use pi equals 3.14. Solution. Given that the volume of water in the overhead tank, that is, cylinder, equals the volume of the water removed from the sump, that is, cuboid. The length L of sump, that is, cuboid shape, equals 1.57 meters. The breadth B of sump, that is, cuboid shape, equals 1.44 meters. The height H of sump, that is, cuboid shape, equals 95 centimeters equals 0.95 meters. The radius R of overhead tank, in cylindrical shape, equals 60 centimeters equals 0.6 meters. The height H of overhead tank, in cylindrical shape, equals 95 centimeters equals 0.9 meters. Therefore, the volume of water in the overhead tank, that is, cylinder, equals pi R square H. This is equal to 3.14 into 0.6 into 0.6 into 0.95. This is equal to 2.14776 meter cube. Therefore, the volume of water in the sump, that is, cuboid, when full equals L into B into H. This is equal to 1.57 into 1.44 into 0.95. This is equal to 1.07388 meter cube. And we need to find the height of the water left in the sump, and also compare the capacity of the tank with that of the sump. The volume of water left in the sump after filling the tank is calculated as the volume of water in the sump, that is, cuboid, when full, the volume of water in the overhead tank, that is, cylinder. This is equal to 2.14776 minus 1.07388. This is equal to 1.07388. Therefore, the volume of water left in the sump equals 1.07388 meter cube. Now, let us find the height of the water left in the sump. The height of the water left in the sump is calculated as volume of water left in the sump divided by the product of its length and breadth. This is equal to 1.07388 by 1.57 into 1.44. This is equal to 1.07388 by 2.2608. On simplification, we get the height of the water left in the sump equals 0.475 meters, which is equal to 47.5 centimeters. Also given that, we need to compare the capacity of tank with that of the sump. So, we find the ratio of capacity of tank to capacity of sump. That is, capacity of tank by capacity of sump. This is equal to 1.07388 by 2.14776. This is equal to 1 by 2. Therefore, the capacity of the tank is half the capacity of the sump. Example